Okay, the first example we're going to look at from the 3.2 homework is number 9. So this one is saying use natural logarithms to solve this equation. We have e to the negative 0.749t equal to 4. Remember, just using basic operations like addition, multiplication, subtraction, that kind of things, we're not going to be able to solve for t. It's impossible. We have to use natural logarithms to get that t out of the exponent. How? Well, the key here is I'm just going to take the natural log of both sides. And remember, I can do this even if the base of the exponent isn't e. Even if the base of this exponent were 10 or 5, I can still use the natural logarithm on both sides to undo the exponentials. So what does this leave me with? Well, the right side, of course, is just natural log of 4, which you could go ahead and plug into your calculator if you want, or you can save that to the end. But the left side, I'm left with natural log, or log base e, of e to the negative 0.749t. Now, a couple different ways I can go about it from here. First of all, I could recognize that because I have log base e of e raised to a power, these can just cancel, and I'm left with negative 0.749t, and I can just solve from there. But if we have a hard time seeing that, I can also use my log property number 5, which of course tells me that if I have a logarithm of a value raised to a certain power, that I can bring that power outside. And that leaves me with negative 0.749t times the natural log of e. And then what's the natural log of e? What's log base e of e? That's just 1, because e to the first power will give you e. And so you'll notice we're left with the same thing. Negative 0.749t equals natural log of 4. And then from here, you can just solve for t by dividing, and you can plug that into your Pearson. Just be careful about rounding. If it asks to a certain number of decimal places, just be careful of that. And it's always a good habit to wait to evaluate stuff until the very end. So natural log of 4, it's probably a good idea to wait until now to go and evaluate it so that you're not rounding multiple times. Okay, the next problem we're going to look at is number 11 from your homework. And here we get a chance to actually take a derivative. So we have the natural log of x to the 6th over 2. Notice we have a function inside of my natural log function. Well, that gives me 2 possible ways to take the derivative of this. First, I could use the chain rule, or I could use log properties. Let's start with using the chain rule. The chain rule says I take the derivative of the outside function. What's the derivative of natural log? Well, I get 1 over, so let's see, f prime of x is going to equal 1 over my input. I don't want to just put x here because I'm not just doing the natural log of x. This is the natural log of x to the 6th over 2. So I get 1 over x to the 6th over 2. But then, because I have a function inside my natural log, I have to multiply by the derivative of the inside function. Well, what's the derivative of the x to the 6th over 2? Luckily, that over 2 is just a constant, so I can just keep it there. And I get 6x to the 5th over 2. Okay, that's pretty ugly, but I can simplify this by just putting the derivative over the original function, right? That was kind of my shortcut rule that we learned in the concept video, is you can just do the derivative over the original inside function. And I can simplify from there. Those 2's are going to cancel, and I'm left with 6x to the 5th over x to the 6th. Well, x to the 5th is just x times x times x times x times x. And x to the 6th is 6 x's multiplied together. So 5 of those x's are going to cancel out, leaving me with just 6 over x. Okay, not bad. But there was some pretty serious simplifying that I had to do. Instead, let's think about using my log properties. If I have the natural log of x to the 6th over 2, what log properties can I use? Well, first off, I can use log property number 4, which tells me that I can split this up into 2 different logarithms separated by subtraction. Why? Because I had 2 things that were divided inside of my natural logarithm. Now I can look at this piece and say, hey, I have a number raised to an exponent inside of a logarithm, which means I can use property number 5. And I get 6 times the natural log of x minus natural log of 2. And so now what we've done is we've used log properties to break this down to the point where it's longer, but it's a lot simpler. Now what happens when we take the derivative? So the derivative of this is the same thing as just taking the derivative of this. What's the derivative of 6 times natural log of x? Well, my constant multiple property of derivatives means I can just keep the 6 there and multiply it by the derivative of natural log of x, which natural log of x, my derivative is just 1 over x. Minus, what's the derivative of natural log of 2? Now this might be tricky. What's natural log of 2? It's a constant. It doesn't depend on a variable at all. It's always staying the same. So what's the derivative? The derivative is just 0. What do I get when I simplify this? I get 6 over x minus 0. I don't need to write the minus 0. And I get the same exact thing that I got when I did it using the chain rule. So you can look at both of these ways and decide which one you like better. Do you like using the chain rule, or do you like using log properties to break down your problem, to break down your equation first before taking the derivative? But either way, you get the same thing. Okay, good luck with the rest of the homework. Please reach out if you have any questions, and I'll see you in the next video.